Yeah, on the bench at the moment is my Schaffner fast transient burst generator. I've just had to fix it. The output stage had gone, but it's working now, and just a blown transistor and a capacitor. So I've just put it all back together. I'm just about to test it, but before I do that, I thought I'd give you a tour around it and inside. It's quite interesting. This equipment is used to generate high voltage noise transients down the mains wiring. This is where the mains connects for your unit under test, whatever it is you're testing the immunity of, plugs in there to the mains. And you've got various outputs and inputs, and you can induce the interference on any of the three lines, 1 or 2 or 3, any combination, by switching these switches in and out. All right, so we've got levels of 1, 2 and 4 kilovolts for the spikes, the interference that's going to be sent down the mains, and then the different types of burst. You can have bursts of pulses. You can have 50 hertz repetitive burst, a single which you can trigger manually, or you can trigger from down here with the logic input. You have a monitor here for your scope, so you can see it's 100 to 1 tap off the output to see the pulses that are being generated and imposed upon the mains. And then you've got also the burst frequency. You've got 2.5, 5 and 10 kilohertz, all right? And also you've got round here, you've got a manual amplitude. You can turn the manual amplitude up and down, and just to see where the point at which the interference kicks in and has an effect on the unit under test. So if we have a look at the inside, you can see you've got the electronics here which generates the burst. It's based on socketed logic chips, which is quite nice because when it destroys itself, you can just swap the chips out and hopefully get it working again. Power supply down in the bottom, just an ordinary switch mode power supply that runs off the mains, and some more electronics. And then down under here is the part I've just been taking apart and put back together, is the power amplifier. Now the pulses from this is quite interesting really. If you look at where the back of the unit here, I'll go around the back and show you, but this is the mains input for the power for this unit. This powers the equipment. This is the mains input for your unit under test, okay? And that wiring just goes up to a switch at the front, which is the UUT switch. So that's power to the socket on the front down here, and then goes back through and is isolated from the input mains by these inductors. There's two big inductors in the live and neutral lines here, and if we follow those wires around, that's the unit under test power coming through there. So that any high frequency spikes induced on this side will be isolated from the input mains from that socket by these inductors on the live and neutral. All right, and there's also a couple of filter caps. You can see those caps strapped across the conductors to earth there to make this filter effective. Okay, so now if we go through and follow those wires through, you can see the wires go through to 3 inductors down here. All right, so this is further isolating the input wiring from the output connections, which are these 3 connections down here. These three connections, 1, 2, 3, go to the power socket on the front here. Right, so that's where the power is. And then if you look carefully, if I move around towards the back of the unit, get a better view. There's the 2 sockets there. There's the 2 mains input sockets, the input to power this unit and the input to power the unit under test, right? So anyway, going back to this area which we were talking about just now, you can see that out of the amplifier is coming this drive wire. Okay, so the spikes come up here at high voltage and they are connected or coupled to the wiring by these 3 banks of capacitors via this switch. Okay, so there's the input spike wire line, and they're connected by those 3 isolation switches on the front to these capacitors, these groups of capacitors, and those capacitors in turn are connected to the output connection. So by putting a high voltage spike onto this wire from the amplifier, you couple those spikes through to the mains for the unit under test via these inductors. And the job of these inductors is to make it ring, and also to isolate, to provide a high impedance for the spikes going back down and interfering with other equipment on the mains. This is where we need the interference being introduced and fed out of the machine. We don't want it coupled and drained away by a circuit which has got a low impedance at a high frequency. Okay, So these inductors are just isolation inductors for the output, and then on the output from these also is a ferrite collar on all the wires, all the conductors going to the output. So that's how it works. It's a very good piece of kit for, as I say, destroying cheap commercial electronics. And if you've got things locking up or crashing, then you would first turn to one of these things to see if it's interference coming down the mains that might be crashing something like a checkout or a bank teller machine or any piece of equipment which suddenly falls over. Is it the mains, and can it survive interference from the mains at pre-specified levels by various standards? Okay, so it's an expensive piece of kit, but it is invaluable if you want to actually design something that's going to be robust and not crash every time a noisy voltage spike comes down the mains. Anyway, I'll show you this in action in a future video. I'll get round to putting something onto it, and we'll test some normal consumer equipment on this and just see how it measures up, okay, and whether it can survive. So anyway, if you enjoyed the tour around this, then subscribe to the subscribe button down there if you haven't already, and leave me a like, and I'll much appreciate that. So that's the Schaffner fast transient burst generator for generating mains interference and destroying cheap consumer electronics. It's quite good fun.